Hey guys, welcome to lesson 9. We're done reviewed through the practice packet. So all the things that we shouldn't have done, but you may have missed some or have some gaps, and that's what we're going to try to fill in today. So open up your practice packet. We can start right on page 1 and start with those first exercises. I'll try to do one from each page so that you can get a handle on it. The first thing is we were talking about the history of the atom. You'll notice Dalton created the cannonball theory of these small atomic particles that are super solid. They're like, but they're like homogeneous. They're just cannonball nature. But it was Thomson who discovered there was a negative particle within them and a positive part of them. So he thought of them as positive, negative, and some sort of plum pudding. So plum pudding model is what he called it. Then Rutherford did the gold foil experiment, which we reproduced in lab. He discovered that most of the atom is empty space. At the very center of the atom is a dense positive core called the nucleus. And so you want to remember empty space, Rutherford. Bohr, or orbitals, as you can remember. Orbitals or Bohr created orbits for those electrons, different energy levels. And the final step is to say, yes, orbitals exist. Yes, they're positive and negative particles. Yes, all those previous models were fine. They all led us to this, but there was a special idea of electron clouds being probable natures, where it's probable an electron is right here, but it could be right here. At that energy level, you can determine the position, but maybe not the path of any particle at any given point. All right, hopefully you got all of those models right. And then we'll look at all the questions in our practice packet. Let's take a look at these. I do like this one, so let me just erase this. Number 6, which of these sequences represent the correct completion of the modern model of the atom? First of all, empty space, so that is correct. An atom with a hard sphere. That is correct, but the wrong order. That should be first, before the empty space one. So this guess is wrong. Most of the atom is empty space. We really would like, that would be before electrons exist in orbitals. Yeah, and then the atom is a hard sphere. Everything was good until this one. This hard sphere model is Dalton. That was one of the first models. It was the first model. The atom is a hard sphere, correct. Most of the atom is empty space. Thank you, Rutherford. Electrons exist in orbitals. Thank you, Bohr. And those are all correct. So option C. Let's go to the next page. You might have different questions on different pages. You know what? I'll go through the answers to these just so you can ask questions in class. Don't bother copying them down if you haven't done them. Just check your work once you have completed them. Questions 1 through 4 are C, A, D, and question 4 is A. Okay, for questions 5, it is A, 6 of course is C, and 7 is C, and 8 is B. All right, let's move on to the next page. Atomic theory. Base your answers on the given model based on this table. So which model correctly describes the location of atoms of protons and electrons in the wave mechanical model? All right, so first of all, location of protons in the nucleus, that is true. And the protons in the nucleus, correct. Dispersed throughout the atom, definitely not. Dispersed throughout the atom, definitely not. All right, let's take a look at this. Electrons, specific shells, that looks right. Probable location. So these two both look correct. This is for Bohr, so not the wave mechanical model. This is for the wave mechanical because it has the word probable. So it's option B. Okay, the rest of the answers for that page, let me just take a look and go through them. 10 through 12 is 10 is A, 11 is B, and 12 is C. 13 is B, 14 is A, and 15 is C. All right, let's take a look at the atomic structure worksheet. All right, so just try to recall that these seem intimidating, but you just break it down. Let's take a look at let's do this column right here. And it seems pretty tough because they don't give you much information. They just give you the number of electrons is 40 and its mass number is 89. So we're going to need our periodic table, and I want you to take a look at element, well, based on this, we have element 40 because its electrons is 40, and so we have to just find element 40, which is ZR, and then we know its mass number is 89, which is okay. We don't need anything else other than ZR as a symbol, so let's go back here, and we now know this is zirconium, and its atomic number for zirconium off the periodic table is 40. And those of you who aren't sure how I got that, I think you'll see. It's right here. Zirconium's mass number, or atomic number, is 40. Number of protons always equals the atomic number. The number of neutrons, though, is the mass number minus the number of protons. All right, so if we know the mass number is 89 and it has 40 protons, that means it must have 49 neutrons. We already know electrons and protons. That's an example of one. Let me briefly show you some other ones, just to make sure you're off to a good start. There's the answer to the first four. If you have any questions on these, make sure you check base with me. All right, let's move on to the next page. These were fill in the blanks. Here's platinum. To do these, don't stress too much. You just have to know platinum, and you need to go ahead and you're welcome to look on the periodic table to find what you believe is platinum. But if you're not sure where platinum is, okay, that page, yep, you just turn the page. It's let me make sure it's on there. It should be right there. Scanning through here, you see platinum. PT is the symbol, and that's what we needed. Oh, we don't really need it other than to find it on here to find our information like the atomic number, which tells us the number of protons. So it's atomic number 78, so it has 78 protons. Oh, I should go back to the other page because that's what we're filling it in. So we have 78 protons, 78 electrons. How do we find the 117? Well, on the periodic table, it should have the mass number, in this case 207. All right, and then you minus 78. All right. What is the name of an element that has a neutral atom that contains so forth? Let me do a hard one like 82 protons. Just take a look at the reference table, and we're going to look for element 82. 82 is Pb, also known as lead. And what's the name of the element? You just have to switch back here. Pb, and it's lead. And if it's not on the table, you can just Google it, right? Let's move on. These are very similar to the ones we just did. I think I did some in class, but let me do maybe the last one, lithium ion. Is there any other tricky ones? Well, actually, I'll do copper, or one that we haven't done. Let me do number, yeah, that's a good one. Sink it to last one right here. We'll fill this one in. All right, what are we given here? We're given, it looks like the number of protons and the number of neutrons. Well, that's nice because we need to remember that the sink it to last numbers. Mass number, which means mass number, I'll write this down so I don't forget, is equal to protons plus neutrons. So that's going to be 50 mass numbers. And then what are the other data? I'll just move right to the right. If it's not an ion, then the protons equal the number of electrons, so it's also 23. This is protons and neutrons. And then this one I miss is atomic number and symbol. Okay, so its atomic number must be 23 as well. And if we know the atomic number, we use the reference table and find element 23, which is V. And if we're not sure about pronunciation, we just flip it over to page 10. And let's say we see element 23, but we don't know what it's called. Turn the page, find element 23, that's vanadium. All right, and that's that page. All right, so we are making some progress. How do we find protons, electrons? Well, there's some examples I already went through. 74 protons, that means there's 74 electrons. And if it's, what is the full chemical symbol? I don't notice anything bad here. Oh, if it has 74 protons and 68 electrons, that means it must have lost 6 electrons. So the element is element 74W, which is tungsten. But it has a positive 6 charge because it lost 6 electrons. So now we're shifting to where we have to deal with ions. Here's some examples from here. All right, let's take a look at some of these. We got, let's take a look at copper. Choose color here. Atom or ion has a charge, so it's an ion. Protons, just look at copper on the reference table. You'll see copper is element number, where's my good friend copper? 29. So it's 29 protons. It doesn't give you the number of neutrons, so copper will be mass number 64. So I'll write 64 right here. Knowing that, I can just subtract the number of protons and get my neutrons. So that would be 35 neutrons. And then the number of electrons. Now, don't forget, there's plus 2. That means it lost 2 electrons. So normally, it would have the same number of protons as neutrons, but it lost 2 electrons, so it's 27. And the nuclear charge always stays the same. It's always a number of protons. All right, so that's how you do that page. Here's the next page, just to check your work. All right, these are tricky. Let me just do one more set, and then I'll probably finish this video to keep it nice and short and start again on the next one. I'll do actually one that's a little farther down. It doesn't matter which one. Which one would be good? These are word problems. Sometimes these can be tricky. All right, so we have some element mixture with 2 isotopes. I'm going to highlight the isotopes in different colors. This is isotope 21, and it contains 50%. Isotope X22, 65%. Isotope 23 with 20%. The reason I do that is to keep things straight. Now what I do is I take its mass number, that's X21. I take its mass number and multiply by its percent abundance. And its percent abundance has to be written as a decimal, so you have to change the percent into a decimal by moving the decimal over 2 places. And then I'm going to do X22. And that is a mass of 22 because it's 22, X22. Its percent abundance is 0.65. And then we have 23, I believe, yep. And its percent is 20%, which is 0.20. Now what we do here is we multiply each of these out, keeping track of significant digits. And let me just zoom in.
Could a custodian please call the main office? Custodian, please call the main office.
So we take
Thank
21
you.
times 0.15, and we take 22 times 0.65, and we take 23 times 0.2. And then we add these three together. So 4.6 plus 14.3 plus 3.15. We get 22.05. So let's finish that up. So we got 3.15, 14.3, and 4.6 all add up to 22.05. And that will be our atomic mass it's atomic mass units. Okay, that's pretty much the same for all of these problems. I think I'll stop there and maybe do another video